Dynamic Building Design by Fatima and Alia. In order to increase the energy consumption and reduce the heat effect on the buildings, sustainable building designs are suggested. Architects adapted a new concept of sustainable building design called dynamic architecture, in which building can change external shape in a systematic way in response to external environment factors. Kinetic facade is a concept of dynamic architecture, where the movement applies on the building surface. The project aims to design a clinic that serves a residential area, using a modern dynamic architecture throughout integrating a kinetic facade concept inspired by biomimicry design, in a way that keeps people inside the building comfortable by using the benefit of the outdoor climate. The United States is the third most populated country in the world. New York City is located in the northeastern side of the United States, approximately halfway between Boston and Washington, D.C. New York City considered as the most populated city in the U.S. The land is located in the southeastern side of New York City, and exactly in Queens community, and it's located exactly on the Howard Beach, a mile away from DC, and 10 minutes drive from John F. Kennedy International Airport. The land lies in a residential area and is surrounded by houses from all sides. Climate in New York considers composite. It's hot in summer and cold in winter. New York City is located on the coast as well as it is on the edge of a continent, where different masses of air collides. Cold air comes from Canada and warm air comes from the Gulf of Mexico. Therefore, it results to unstable climate and frequent wind blow on the area. The weather ranges between -2 in winter and 29 in summer. The average wind speed in Howard Beach is between 5 to 8 meters per second, and most of the wind comes from the southwest side.
In our project, the kinetic facade will be inspired by date palms. The leaves of the date trees will be reflected in our design as a kinetic facade. The leaves act as a component that will allow the building to function better in different weather situations over time. The leaves will also be providing an appealing innovative feature to the architecture of the building. The proposed kinetic facade method is the rotation strategy, where the model rotates around a single vertical or horizontal axis to achieve the aim of motion. The kinetic facade will act as a second layer that works and transforms according to the sun position to manage light, heat, fresh air into the building. Timber wood will be the material used for the movable parts of the kinetic facade that will be representing the leaves of the date palm. Our design have evolved from a normal U-shaped building to a building that have 3 squares intersecting, mimicking the leaf of the palm tree. In the design process, we have listed the zones of a clinic and proposed a layout plan. In the last step of the design process, we came with the base case design of the clinic. For the IES analysis, we have chosen the timings as shown below in the figure. For winter, January 25th, spring, May 15th, summer, July 26th. We also have chosen 9 a.m., 3 p.m. and 12 p.m. to do the analysis. This clip shows the solar path for the full year. The analysis of the sun exposure helped us drive our kinetic facade strategy. The materials of walls, roof, and windows were enhanced in the efficient case based on the Green Building Code in USA. For the efficient case, we have modified some of the materials. For example, we used green roofing for the roof, double glazing windows for the windows, and we also added insulation for walls to reduce the U value.
Since it is a public clinic, it should have a special cooling and heating profile. It should be opened all days during the week and weekdays except for public holidays. And the clinic opens from 6 a.m. to 10 p.m. In winter, there is no change in the air temperature between the base case and the efficient case. The air temperature remains the same. In January, there was a big solar gain reduction from the base case to the efficient case. At 9 a.m., there was 87.7 solar gain reduction, which is the highest percent between all timing. And at 12 p.m., there was a 70.4 solar gain reduction. And at 3 p.m. there was a 35.4 solar gain reduction. In the daylight factor, luminance test was applied on efficient case and base case. In the efficient case, there is a decrease in the glare because of the application of the kinetic facade. May, there is a slight reduction in the air temperature from the base case to the efficient case. There is a 1.8 reduction at 9 a.m. and at 12 p.m. there is a 7% reduction, and at 3 p.m. there is a 6.8% reduction in air temperature. The solar gain reduced almost half between the base case and the efficient case in May. It reduced from 54% to 59%. In the daylight factor, there is a huge reduction in the glare between the efficient case and the base case because of the kinetic facade. There is a slight air temperature reduction in July. The reduction ranges between 8% to 13%. On the other hand, there is a huge solar gain reduction in July. The reduction ranges between 56% to 71%. There is barely seen in the efficient case in July. Because of the direct sunlight, the kinetic facade is almost closed.
Comparing the base case and the efficient case, the total energy consumption has reduced by 75%. After comparing the base case and the efficient case, the maximum daylight factor has reduced by 54.72%. To add renewable energy in the building, around 24 to 30 panels of PV should be added.
And finally, a designed facade system can help in increasing the energy efficiency of a building, and it also can help in with occupants' comfort level and productivity.